Okay, so today we're going to be looking at LeetCode question 121, which is best time to buy and sell stock. LeetCode question 121 is an easy question, and the problem goes as such. You are given an array prices where prices index I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. And what we're going to be doing is returning the maximum profit you can achieve from this transaction. And if we cannot achieve any profit, we're just going to return 0. As I said before, we're going to be giving this price array, and inside of our array we have these values. And so what we're going to be doing is we're going to be looking through this array and seeing what two values are going to give us the largest profit. So in this case, if we look through this array and we take two values that together, if we subtract this farther value and then minus this lower value, is going to give us a profit. So the variables that we're going to be saving as we go along is going to be our minimum value, which is our minimum profit value, and then our maximum profit value. We're going to be going through this array, and we're not going to be using the sliding window approach. That is another way to solve this problem, but we do not need a subarray here to solve this problem. We're going to instead use a dynamic programming approach. The reason for that is that we're going to break this problem down into a subproblem, and we're going to just go through the array at a time of O of n and a space of O of 1, because we're only going to go through our array one time. So we're just going to look through this array and we're going to go through it one time, and we're going to just see which is our minimum value, minimum p, that is going to be our first minimum value, and then we're going to look for our maximum value, which is going to be, as we go through this, we're going to take this max minus this min, and we are going to see what is our maximum profit. So in this case, this one is 5, and the reason being is that we go on day 2, which is 1 in our array, index 1 in our array, and it's also value 1, and we're going to have that be our starting price. So we buy our stock at 1, and then we're going to go on day 5, which is this 6, and we're going to sell right here when the value is 6. And that's going to lead to 5 right there. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. So you can't just go ahead and, you can't, because this 7, like, yes, if we had 7 back here, we would have a profit of 6, but because that 7 is earlier, that would be a negative profit right here. So between 7 and 1, we're going to have a negative profit of 6. So we are actually going to be losing money if we do it that way. So we're going to go down here, and we're going to take a look at this graph that I've created. And this graph on our x-axis is going to signify our index values. So we have 0, 1, 2, 3, 4, 5. And the index is going to be here. And it's going to just be traveling along as we go through the problem. And right here on the y-axis, what we have is our array values. So our highest array value is going to be 7 right here. So this goes up to 7. So if we plot our graph at our first value here, 1, or our first value here of 0 at index 0 is 7. So if we plot here, we have 7. Then if we move over to the next value, we have 1. And so what we're also going to do at the same time is save this as min and max. So max is going to be our maximum profit that we're going to receive by subtracting our values from each other. So 7, minus 1, like if that was the case, which is not, because it's going to actually be 1 minus 7, which is negative 6. So right now our maximum profit is still just going to be 0, because we're just going to leave it at that at the beginning, because right now we do not have a max profit. And our minimum profit right now is going to be, because we just moved to 1, it was originally 7, because that was our minimum value, But now if we take 7 versus 1, 1 actually is now our minimum value. And so as we go along to 5, we can plot up here at 5. And I'm also going to make our little here. So we're going to plot at 5. And if we actually take that value and do 1 is still, so if we take the difference between 1 and 5, 1 is still smaller, so that's still our min. But our maximum profit changes because 5 minus 1 is going to be 4. So right now our max profit is 4. So if we go to the next value of 3, our value, our index 3, and then the value is 3, we're going to plot that here at 3. And we're going to connect that point right there. We are going to notice that these values are not going to change because 3 is greater than 1, so our minimum value is not going to change, and 3 minus 1 is 2, and our max profit right now is 4. So that's not going to change at all because we're saving this as we go along. Now, next, we're going to go to the next value in our array, which is 6. So 4 equals, so our index 4 equals 6, and then if we plot that, we are going to notice that, okay, so still with our minimum, 6 is greater than 1, so this 1 is not going to change. That is still going to be our minimum value of where we want to buy at. But our maximum profit is going to change because what's going to happen here is 6 minus 1 is going to be equal to 5. So this 5 is greater than 4. Therefore, our max profit right now is 5. And so we can now complete this by looking here, because we don't know yet. We haven't gone through the whole array. This could be, a 7 right here, an 8. We could have a much larger profit. We don't know that yet. So if we go to our last value, it's going to be 4. And if we plot that here, we can see that 4 is still greater than 1. So this minimum doesn't change. This is not going to be our new minimum value. But 4 minus 1 is equal to 3. So that would only leave a max profit of 3. Our max profit right now is 5. So 5 is going to be our value. So we're going to take this over to Visual Studio Code. And what we're going to do here is first just create our function called max profit. And inside of it, we're going to put our prices array as our variable. And then what we're going to do first is we're going to create an edge case for just in case our array does not have enough values in it to be able to make a max profit determination. And what we're going to do first is we're just going to add that here. And so we're going to take if len prices is less than 2, return 0. And after that, what we're going to do is we're going to add a float at negative infinity. So we're going to add our variable max profit, and we're just going to call it max p instead. I just like to keep it a little bit more succinct, but you don't have to do that. And then we are going to add float negative infinity. And the reason, and make sure you do add the float, because if you don't, it's not going to work. And this is a negative. And the reason for the negative infinity is so that we can account for even a negative profit value. So it's possible that in our array, and let's actually draw our array up here. We're going to just add that in just so that we can kind of visualize it the whole time. 5, 3, 6, and 4. So in like the situation here, so we had the 7 and we had the 1. 1 minus 7, which is how this is going to go because profit goes this way. 1 minus 7 is negative 6. So that's going to be able to, our max profit here would be negative 6, so it's able to change that value for it. But next we're going to create our other variable, which is going to be our minimum value, which is our we're just going to call it minimum p, which is minimum profit value. And that is going to just start as equal to the first value in our array. So right now this min p is starting at 7. And then next we're going to begin to loop through the array. So for p in prices, we are going to go through our array, and our max p is going to be equal to the max between our current max p, which is negative infinity, so it's just any number. It could be 0, whatever we have right now, which is, we'll just pretend it's 0. And then that's going to be compared to what our current profit is minus our minimum P. So the minimum P we haven't created yet down here, but it's going to be our profit, and so right now it would be 7 minus 7, which is 0, so currently it's 7 minus 7 equals 0 because our P is at 7 and our min P is also equal to 7, so we'd have no profit right now because we haven't moved at all. And then our minimum P is going to be equal to the minimum of min P and profit. So as we go along, we're going to be looking to see what is the new min. So like right now our min is going to be equal to 7 because we just started, but when we move over 1 and we go to the next value, which is 1, our minimum value is going to be between 7 and 1, and that is going to equal 1, which is going to be end up being our minimum value. This is going to allow us to go at an O and N time because we're only going to have to go through our array one time, and so we're only going to be restricted based on the size of the array. That's how long it's going to take no matter what, is how long this array is. And so after that, we're just going to return max P, max profit. And what we can do down here is we can print our value. So max profit is going to have the array 7, 1, 5, 3, 6, and 4 inside of it. And what we can also, and so let's first just test this, make sure this works. Alright, so we get our value 5, just like how we knew before. But what also is cool is that if we add in, so let's add some print statements in here, and just so we can kind of take a look at where it's going. So we add this print here, and this print min P, and we're going to run our code, and we can get rid of that. And as you can see, so it starts off as negative affinity. This is the first round, which is max P equals negative affinity, min P is going to equal 7, and then our next is going to be, because that 7 minus, this was going to be equal to 0, so that's our current max P here, which is 0. And then the next value is going to be our min P, which is our min P versus P, which was 7. So that was our current minimum profit, was 7. And as we go along, so our next one, so as we move to 1, we now still have our profit, our max profit is 0, but our minimum price is going to be equal to 1 now, because we're going to compare 7 and 1 to it. And as you can see, it continues down as we move through it, and eventually we get our answer of 5, which becomes our max profit, and that's what we return. So I hope that helped you out. If you liked this video, please subscribe to my channel, it really helps me out, and also please like and comment for other videos similar to this. I'm going to be continuing my Blind 75 playlist, so look out for my next videos to get more information on how to solve these kind of problems. Alright, thank you, bye.